Imagine your digital assistant not just fetching the weather or playing a song, but proactively managing your entire workday, anticipating your needs before you even voice them, and solving complex problems without a single command from you. This isn't a scene from a distant sci-fi future, it's the tangible direction in which artificial intelligence is rapidly advancing. We've all grown accustomed to AI assistants in various forms. But what if I told you there's a new breed of AI emerging? One that doesn't just follow orders but thinks, plans, and acts on its own initiative. This is the burgeoning world of Agentic AI. Daily we interact with AI agents, the chatbots that guide us, the virtual assistants on our phones, the algorithms that recommend our next binge watch. These are systems meticulously designed to perform specific tasks. But Agentic AI represents something far more profound. It's an overarching concept, describing systems capable of autonomously pursuing complex goals with only limited supervision, marking a significant leap in AI's inherent capability. The terms AI agent and Agentic AI are frequently and understandably muddled in common discussion. This is partly because AI itself is evolving at such a breakneck pace that the very language we use to describe it struggles to keep up. The idea of an agent in AI isn't new, it has roots stretching back decades in computer science. What is new is how this concept is being supercharged, leading to Agentic AI, a term signifying a qualitative jump in what AI can achieve. Clarifying this distinction is vital, not just for tech aficionados but for everyone, to truly grasp the capabilities and the potential societal shifts these advancements herald. If the public mistakes a sophisticated Agentic AI for a simple chatbot, they might dangerously underestimate its power, or conversely, overestimate the intelligence of more basic systems. This journey from basic AI agents to Agentic AI isn't arbitrary. It reflects a fundamental ambition within AI research, the quest for greater, more meaningful autonomy. Early AI systems were largely confined to specific, often narrow tasks. The inherent limitations of these systems naturally spurred the drive towards creating more independent, adaptable intelligences. Agentic AI, with its defining characteristic of operating with minimal or no human intervention and limited direct supervision, stands as the current zenith of this pursuit. This isn't merely about enabling AI to do more, it's about empowering AI to be more independent, more capable of navigating unforeseen complexities. In this exploration, we'll unravel these differences, delve into their capabilities, and understand the profound implications of AI agents versus the more sophisticated and potentially revolutionary Agentic AI. We'll see that while AI agents are often reactive and task-specific, Agentic AI is fundamentally proactive, goal-oriented, and profoundly adaptive. Our journey will take us through the nuts and bolts of AI agents, then plunge into the groundbreaking concept of Agentic AI. We'll compare them side by side, examine mind-bending real-world applications, and finally, contemplate the exciting and admittedly challenging future they are collectively forging. Decoding AI Agents. The digital workforce you already know. But what exactly is an AI agent? At its core, an AI agent is a software program or system designed to perceive its environment, make decisions based on that perception, and then take actions to achieve specific, often predefined goals. It acts on behalf of a user or another system. A classic academic definition describes an agent as anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Key characteristics often include a degree of autonomy, programmability, reactivity to environmental changes, and sometimes proactiveness in pursuing goals. Crucially, an AI agent is often a specific component or a tool within a larger system, designed to handle particular tasks and processes with a measure of autonomy. But how do these agents actually work? They generally operate through a cycle. First, perception. They gather information about their surroundings. This could be through physical sensors on a robot, text or voice input from a user, data from APIs, or information retrieved from databases. Next comes decision-making. The agent processes this collected information. It uses algorithms, predefined rules, or in some cases, basic machine learning models to determine the most appropriate action to take based on its goals. Finally, action. The agent executes the chosen task. This could range from moving a physical robot to displaying information on a screen, sending a message, or classifying a piece of data. Some AI agents also possess a capacity for basic learning. They can refine their performance over time, but this learning is often confined within narrow parameters. Think of a spam filter that gradually gets better at identifying junk email based on your feedback. Architecturally, a typical AI agent might include a knowledge base to store information, a reasoning engine, which for simpler agents is often rule-based, and potentially a learning module to facilitate improvement. The fundamental structure comprises the underlying hardware or system, the architecture, and the software program that dictates its behavior, the agent program. It's important to recognize that many common AI agents, like some chatbots or voice assistants, can create an illusion of intelligence. They might seem to possess a broader understanding than they actually do. These systems often operate on relatively straightforward logic or sophisticated pattern matching. However, their ability to process natural language, even if it's a shallow understanding, or perform tasks quickly, can lead users to anthropomorphize them or overestimate their cognitive depth. Understanding this sets a crucial baseline. When we later delve into agentic AI, the contrast will be far more striking if we appreciate the true, often limited, nature of the agents we currently interact with daily. This helps manage expectations and underscores why agentic AI represents such a significant evolutionary step, moving beyond pre-programmed responses towards more genuine understanding and reasoning. AI agents are not a monolithic category. They exist on a spectrum of autonomy and intelligence. This spectrum shows an evolutionary path even before we arrive at the concept of agentic AI, demonstrating that agency itself isn't a binary on-off switch. Let's look at some common types. Simple reflex agents. These are the most basic. They act solely based on the current information they perceive, ignoring any past history. Think of a thermostat that turns on the heat when the temperature drops below a set point, or an automatic door that opens when it senses someone approaching. Basic email spam filters that flag messages based on keywords also fall into this category. Model-based reflex agents. These agents are a step up. They maintain an internal model or state that reflects their understanding of the world, allowing them to keep track of aspects of the environment they can't currently perceive directly. For example, a self-driving car component might remember the location of an obstacle it has passed, or an advanced robotic vacuum cleaner might use its internal map of a room to clean more efficiently. Goal-based agents here. Actions are explicitly chosen to achieve defined goals. Their decision-making can involve more complex processes like planning and search algorithms. A GPS navigation system calculating the best route to your destination, or a Roomba planning its path to clean an entire room are good examples. Utility-based agents. These agents are more sophisticated in their decision-making. They aim to maximize an expected utility, a measure of happiness or desirability. This allows them to make trade-offs between conflicting goals or uncertain outcomes. A self-driving car balancing the desire for speed against the need for safety and passenger comfort, or a financial trading bot optimizing for maximum profit while managing risk, would use utility-based approach. Learning agents. These agents are designed to improve their performance over time through experience and feedback. Recommendation systems like those on Netflix or Spotify, which learn your preferences and suggest content you might like, are prime examples. Speech recognition software like Siri or Google Assistant, which get better at understanding different accents and slang over time, also fall into this category. While incredibly useful, these AI agents have their limitations. They are excellent at automating repetitive tasks, processing information rapidly, and providing assistance within specific, well-defined domains. However, they often struggle with generalization. An agent designed for one task typically cannot easily adapt to a completely new and different domain. They can also be brittle or lack robustness, performing well under expected conditions but failing when faced with unexpected inputs or novel situations. Scalability can be an issue, as the computational resources required can grow exponentially with task complexity. Many are heavily reliant on their predefined rules or initial training data, limiting their flexibility. Furthermore, if an agent requires frequent human intervention or doesn't offer a clear benefit over performing the task manually, its value generation is diminished and it can even compromise user agency. As one source aptly puts it, without the user realizing enough value out of an agent, they may not be willing to use it. Many also struggle with nuanced context understanding or maintaining long-term memory of interactions. This nuanced view of AI agents with their varying capabilities and inherent limitations prevents a simplistic dumb agent versus smart agentic AI dichotomy. It allows for a richer understanding of AI's developmental trajectory and helps explain why some AI agents already seem quite capable within their specialized niches. It also perfectly sets the stage for understanding why the emergence of agentic AI is such a transformative development. Enter Agentic AI, the dawn of truly autonomous systems. Now we arrive at Agentic AI. This isn't just a more advanced type of AI agent, it represents a paradigm shift. Agentic AI refers to AI systems designed to act with a high degree of autonomy, capable of pursuing complex, often long-term goals with limited human supervision. They achieve this frequently by orchestrating multiple AI capabilities or even other, more specialized AI agents. One academic definition describes agentic AI as a system based on a foundation model that performs tasks potentially yielding artifacts based on natural user instructions, where the system is able to conduct and express complex reasoning, including planning and reflection, to solve tasks that require interaction with an environment. The emphasis here is on systems that can act intelligently and independently to achieve complex objectives. It's a crucial distinction. Agentic AI is not primarily about generating content like generative AI, think ChatGPT creating text or Midjourney creating images. Instead, agentic AI is focused on making decisions and taking actions in the world. The engine driving many of these advanced agentic AI systems is often a foundation model. These are very large artificial intelligence models, trained on incredibly broad data sets, which can then be adapted to a wide array of more specific tasks. Their general-purpose nature provides the raw cognitive power that agentic AI frameworks harness for complex reasoning and action. The rise of these powerful foundation models is a key catalyst for the current surge in agentic AI development. They provide the broad understanding of language, context, and some level of reasoning that was previously very difficult to achieve. Agentic AI frameworks then build on top of these models, adding layers for sophisticated planning, memory management, and the crucial ability to use tools. Without the reasoning and language capabilities of foundation models, the cognitive layer of agentic AI would be far less potent. They provide the spark of general intelligence that agentic frameworks then channel into purposeful, goal